Hello students. After learning how to calculate surface area and volume of combination of solids, let's learn on what principle conversion of one solid to another depends on. So that is the today's heading, conversion of solid from one shape to another. As in your textbook, example of candle is there. So we'll start with the same example. Suppose here this is a candle and you can see it is in a form of cylinder. So if this candle, if you will heat, the wax will melt. Okay, so let heat this candle, wax will melt, and now you can pour this wax in any mold of your choice. So you pour it here. Suppose you want a cube, it is in a form of cube or cuboid or any flower shape, animal shape of your choice. So volume before and after molding will be same. Volume before and after molding will be same. So you need to understand here, and you can highlight this in your textbook also. The volume of new candle will be same as the volume of earlier candle. Okay, volume before after molding remains same. Okay, this concept has many application in industry. Suppose if we'll take for example, this is a your metal cube. Suppose this is your metal cube and you melt this to get 100. You melt this cube to get 100 spheres. Okay, so 100 spheres. I can't draw 100 here, but just these are 100 suppose. So if volume of this cube is V, then volume of all the 100 together, if you'll add this plus volume of this will add up to V. This volume also will be V. So volume is not going to change, it will remain same. So here volume of cube will be equal to volume of 100 spheres. So let's solve few examples based on the simple principle. And what is the principle? That volume before and after molding is same. Example 9. Selvi's house has an overhead tank in the shape of cylinder. This is filled by pumping water from sump, an underground tank, which is in shape of cuboid. The sump has dimension 1.57 meter into 1.44 meter into 95 centimeter. The overhead tank has its radius 60 centimeter and height 95 centimeter. Find the height of water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Compare the capacity of tank with that of the sump and use pi equals to 3.14. Let's try to understand the question first. You can see this is an underground sump. This is an underground sump. Okay, and it is in a form of cuboid. Now dimensions are given. You can see the dimensions here. And this is what? It is a overhead tank which is in a form of cylinder, right? Now first thing is here, this is in meter, this is in centimeter, and this also in centimeter. So everything we need to convert in one unit. So conversion of unit is must here, is the first thing. Okay, now we need to find two things here. First is what? We need to find the height of water left. Okay, this is our first thing. And second is compare capacity of tank with that of sump. So we need to compare capacity with that of sump. So let's write down what to find out. Okay, so we need to find what? Two things are there. So first is, quickly you can write it from here, find the height of the water left, and second is what? Second is compare the capacity. Okay, now try to understand. Now some is full of water and then some quantity of water is transferred into tank. Okay, this is full of water. Try to understand this. This is full of water. Okay, full of water. Some quantity is transferred here, right? Then it will be, suppose this height is 95 in the beginning, now it will be reduced. Suppose now the height is this much water only is left here. So this much water is left. Can you see? This much water is left. So first part, find the height. Find the height of water means you're going to find this height, this height. Okay, so let this be h. Let this be h. So we need to find this h. For this, children, first thing is you have to find what is the volume of water in this sump. Then you will find what is the volume of water in this tank, and then you will subtract it to get this height. How? Let's see. Let's see. Okay. Now what is it? Volume of cuboid minus volume of cylinder will be what? So, volume of water, volume of water left in cuboidal sump or left in sump, which is cuboidal, will be equal to volume of cuboidal, volume of sump only I'll write here, volume of sump minus volume of tank, which is in a form of cylinder. Okay, so now first thing is we'll find out volume of sump. So first let's find out this. Therefore volume of sump is it is a cuboid, it is length into breadth into height. Okay, now here L is what? L is 1.57 meter and B is 1.44 meter, and what is H? H is 95 centimeter. You need to convert it to meters, so need to divide it by 100. You will get 0.95 meters. So let's use this to find the volume of sump. So volume of sump is 1.57 into 1.44 into 0.95. Multiply all these things and you'll get 2.147 meter cube. And now next part is what? Next is volume of cylindrical tank. So volume of tank as it is a cylinder, so it is pi r square h. Okay, now again here r is 60 centimeter. That means 60 by 100 will gives us 0.60 meters, and height is what? 95 centimeter. So 95 centimeter converted to meter, you will get 0.95 meter. So let's put the values here. Simply put the values. So it is 3.14 into 0.60 into 0.60 into 0.95. You need to solve this quickly. You'll get answer 1.074. It is volume, so meter cube. Okay, now what is the next step? Now volume of water left in sump will be what? Now volume of water left in sump is, you just need to subtract it. So it will be 2.147 minus 1.074. So just simple subtraction. Answer is 1.073 meter cube. Okay, now this much water is left. This much water is left. Try to understand. If this much water is left, suppose this is your this cuboid. This is your cuboid. Okay, and right, this is your cuboid. Okay, now see here, volume. This much volume is left. Okay, so this much volume is left. This is left, right? This is the water now, new height. So this much volume is left. So volume of left water, this volume of water left is actually equal to this. So it is 1.073 meter cube, correct? Now here try to understand this L. This is L and this is B. It's going to remain same. It will be same. It will not change. Okay. Only this height is changed, but L and B is same. Okay. There is only change in height. So now what is volume of this cuboid? This is a form of cuboid only now. New cuboid. Okay. But here L is same, B is same, only H is different. And in question, it is the demand of the question that you need to find this H. Therefore, volume of this cuboid, so volume of cuboid is what? 1.073, right? You can write here. L and B will be same, correct? Will be same. Okay, for your understanding, you can note this down. Now, what is volume of the cuboid formula? Actually, if volume is 1.073, that means it is L into B into this H, which is equal to 1.073. Now, everything is clear, I think so. Here, only unknown thing is H, because L and B, I'm going to write the same values, right? So, what is L? L is 1.57 into what is B? It is 1.44. H, we have to find out H, and then it is equal to 1.073. So, I'll take H here. Okay. So, if H is here, this is 1.073 and this thing's in multiplication with H. So, it will go in division. So, H is 1.073 divided by 1.57 into 1.44. Now quickly you need to divide this. Answer will be 0.475 meter. Meter only, because it is height. Don't write by mistake cube there. So height is 0.475 meter. We are done with the first part. Therefore, you can write, therefore, height of water left in sump equals to 0.475 meter. We are done with the first part. Now let's solve second part. What is second part? Compare capacity of tank with that of sump. Now children, common mistake here is, it is given compare capacity of tank with sump. That means volume of tank will be in numerator. Try to understand, volume of tank will be in numerator and volume of sump will be in denominator. If you will solve in vice versa, then you are not going to get marks. It will be incorrect. Therefore, compare capacity of tank with that of sump is equal to what? It will be capacity of tank divided by capacity of sump, right? Okay. Now I'll not put the final volume here. What I'll do, I'll put on all the numbers, because then it is very easy to cancel the numbers. That's why I'll put numbers here. So capacity of tank is 3.14 into 0.6 into 0.6 into 0.95. See, divided by 1.57 into 1.44 into 0.95. Now from here, This get cancel. Now you can cancel out this things, decimal, remove this decimal point, this whatever is left. If you'll remove, you will see 1 2 3 4. So here in denominator 1 2 3 4. Similarly, I have removed from here 1 2 3 4 again. In numerator also 1 2 3 4. So all the decimals get cancelled. So you left here with 314, and 6 into 6 gives us 36, divided by 157 into 144. Okay. Now simple your division is there. Just solve it and you'll get answer 1 by 2. Okay. Then write down the final answer. Compare capacity of tank with that of sump. So you will write capacity of tank with that of sump is 1 by 2. Example 11. A hemispherical tank full of water is emptied by a pipe at the rate of 3 by 7 liters per second. How much time will it take to empty half the tank if it is 3 meter in diameter? Take pi equals to 22 by 7. Okay, so this is your hemispherical tank. Okay, and what it is given? It is given that diameter, diameter is given. Yes, diameter is 3 meter. Here diameter is 3 meter, therefore radius will be 3 by 2 meter. Okay, then a hemispherical tank which is full of water, it is full of water. Okay, it is emptied by a pipe at the rate of 3 by 7. Let's convert this first. 4 by 7 is a mixed fraction. Okay, so what is this? 3 7 21 4 25. So 25 by 7 liter water is out every second. Okay, so this is clear. So this is liters per second. So 25 by 7 liter water is out every second. Then how much time will it take? We need to find out time it will take to empty half the tank. This word is important. If, okay, half of the tank, that means first thing is clear that we are going to find out volume of this hemisphere, and then we'll find out half the volume of the hemisphere. So let's start. Okay, so volume of this hemispherical tank, again formula, what is it? 2 by 3 pi r cube. Now just quickly put values. It is 2 by 3 into 22 by 7. Now what is r? R is 3 by 2. So just put it here. 3 by 2 into 3 by 2 into 3 by 2. This 3 get cancel. Okay. This 2 get cancel. Okay. 2 11s are, now this 3 and 3 is 9 into 11 is 99, and we have 7 into 2 in denominator, which gives us 14. So volume is what? Volume is 99 by 14 meter cube. Now next is what? Half of the volume. So let's do this. Therefore half of V is what? Half of 99 by 14, correct? Okay, so this will give us 99 divided by 28 meter cube. Now it is given that 4 by 7 liter per second. So we need to convert this in liter. We need to convert this in liter. Now here you need to write down also there itself beside the question in your textbook, that very important, 1 meter cube is equal to 1000 liter. Okay, so you should be aware of this for the conversion. So let's do the conversion. Therefore 99 by 28 multiplied by 1000. Okay, to convert this meter cube to liter, so multiplied it by 1000. So you will get 99000 divided by 28 liter. Okay, so this much water is out of the hemisphere. Now, how much time taken to get this much water out of the tank? Suppose since you can write here, since time taken to emptied, since time taken to emptied, okay, so time taken to empty 25 by 7 liter is 1 second. It is there in the question. So time taken, time taken to empty 1 liter will be 1 divided by 25 by 7, which gives us 7 by 25 second. Okay, if this is clear, then only we can proceed, right? Therefore time taken to empty, therefore time taken to emptied, what was the volume? It was 99000 divided by 28 liters will be what? It will be 99000 divided by 28 into 7 divided by 25. Simplify this, you will get answer 990 seconds. Now, if you want to convert this second to minutes, okay, we can do this. You just need to, to convert in minutes. So it will be 990 divided by 60. 0 get cancelled. You get here 33 by 2, which in turn is 16.5 minutes. Okay, so this is your answer in minutes.